Yes, determining a determinant using the Laplace expansion theorem or expansion by Laplace. Here you have a matrix, a 3 by 3 matrix, and the coefficients are given accordingly. This would be the coefficient A1, a 1, 1 according to AI, Aij. Now I'll use the general letters I and J. If such a matrix is given, then the theorem applies. We determine the determinant of A, and you can expand either by rows or by columns. It doesn't matter. If we expand along a row, the sum from j equals 1 to n of ai, aij times ci, cij applies, where c, yes, so with ci, cij is equal. That is obtained by multiplying minus 1 to the power of I plus j times determinant, again a determinant of mi, mij, and the mi, mij is then the submatrix. And I'll show you right now how you can break that down. So now we are supposed to determine the determinant here. We expand along the first row, and then the determinant of A is accordingly equal to yes, and now the sum of. We then have a 1, 1 times C1, 1 plus a 1, 2 times C1, 2 plus a 1, 3 times C1, 3. So how do we get there now? Here we have A1, A11. And this is just as an example for the first term. That's the second one. Yes. Then we have to get to C1, C1, 1. 1 and 1 now means we cross out the first row and the first column. Yes, and when the first row and the first column are crossed out, this is what's left, and that's M1, M1, 1. Yes, that's the first submatrix, which we still have to multiply by minus 1 to the power of I plus j, and I and j are both 1, so minus 1 to the power of 2 multiplied. And we still have to determine the determinant of this matrix accordingly, and that will give us C1, C1, 1 times. Now we have to determine the determinant of M1, M1, 1, and then we'll use the formula here. This is a 2 by 2 matrix, and its determinant, yes, so the determinant of M1, 1, yes. 1, that's equal to 4 times 0. Minus 2 times minus 1. That's equal to 0 minus, and minus is plus 2, so 2. So, and with that, we've basically finished this first part. That would then be equal to A1, A1, 1, which is 2, multiplied by minus 1 to the power of 2. That's minus times. Minus is plus, 1 times, and the determinant of M1, M1, 1 is 2. Yes, and that's how it continues. Then we have a 1, a 1, 2. Of course, you can make this clearer for yourselves using colors and look it up more precisely. A 1, a 1, 2 is 3. Then accordingly determine C1, C1, 2 with M1, M1, 2, the next submatrix. We cross out the first row and the second column, yes. So again, the first row and the second column, yes. And then what's left? How should I interpret it? I'll put 0, 5 here. This here is gone, and minus 1, 0 is left. So now we need the determinant M1, 2 right. So these are left now. 0 times 0 minus 5 times minus 1. Yes, that's 5. Then, of course, the multiplication with minus 1 to the power of I plus j. Yes, so now we have 1 plus 2, so we would have multiplied with the whole thing, minus 1 to the power of I plus j, which is 1 plus 2, that's 3. That would be minus 1, so plus A1. Our 1, 2 is 3 times, and C1, 2 consists of minus 1 to the power of 3, which is minus 1 times. And now here we have the next determinant, which is determined by the next submatrix, which is 5. plus, and now the last step, a 1, 3, a 1, 3. 1, 3 is 1, yes, we can also plug that in directly here. 1, now C1, C1, 3 is composed accordingly from the multiplication. Minus 1 to the power of 1 plus 3 is 4. Minus 1 to the power of 4 is again 1, and then we still need M13 and its determinant M13. Cross out the first row again, cross out the third column, and what's left is 0 times 2 minus 5 times 4. And that's a total of minus 20. So once again, minus 20. We still need to calculate everything. So 2 times 2 is 4. 3 times minus 1 minus 3 is minus 15. Here we still have minus 20, so we have minus 15 minus 35. 30 plus 4, the determinant is then minus 31, yes. That was the Laplace expansion theorem broken down with the corresponding formula. I'll put it in the corresponding playlist, which I'll also link here. I also have an example for a 4x4 matrix. For the 2x2 matrix, you already have the corresponding formula to calculate it. If you now have a 4x4 matrix, and then you get the submatrices along with some additional rules, then you should know how to apply them each time. Yes, you could also use Sarris's rule here. Sarris, that's how we always pronounce it. This was just meant as an example with a 3x3 matrix. And then I hope that you'll get through it easily.